Last up here, we just need to take this curve and we need to make an actual geometry out of it. So you know that right now our curve is sort of still in line with our base geometry, right? The same curve that we created our original bridge geometry out of. So we need to basically move a curve off to the side and then move another one off to a side, the opposite side, plus a certain dimension, right? So you need to just think about the math on that. We'll get to that in a moment. But anyway, the most important thing here is this base normal, because the base normal is just that cross reference between the two sides of the bridge. So I'm just going to grab a copy of one. This one right here, copy paste, ink that thing back, and we'll start using it over here. This whole thing, I'm going to slide down. Okay, base normal. Curve, that's good. Turn that stuff off. Let's get in perspective. All right, so we have the curve that we're going to move, and then we just need to go to Transform, Euclidean, and Move. Okay. So the geometry we're going to move is obviously the curve. We need to create a magnitude for this, so we're going to use amplify in this case, vector, vector, amplitude. Plug that in here. The normal is this vector, and then we just need to tell it how far to move. But notice how it's already moving on the inside. We need to move it to the outside. Technically, you could do it either way first. I'm going to start on the outside here. So I'm going to switch this to a negative. Or I guess I could make a negative slider, or I could add a negative. I think what I want to do is use a negative, and I'll explain why when it becomes apparent. Okay, so anyway, I'm going to put a slider here for 0 is less than, let's make it 5 feet. Well, let me make it 0 less than 5.0. Plug that in there. And that's our curve. And I think, something like 2.5 feet is probably appropriate. Where's that bridge? There. Yeah. Maybe, 2 feet or something like that. All right. So that's one side. Now I need to move a copy of this to the other side of the bridge. But I have to consider exactly where I want to place it. Right. My bridge is, we have our 2 guardrails here that have a certain thickness. The thing that we built it off of is the inside face of this guardrail, and we are currently moving 2 feet off to the side there. Plus we have, well, in my case, I have my 10-foot or whatever width of that thing that you have there, and we're going to have to move 2 feet to the other side. So we need to add all these together using our arithmetic tools, right? So we're going to borrow, this value is going to be useful to us. And so I'm going to need to add 2.2 plus 2.2. And then I'm going to need to add that value again. Let me put this way. I'm going to need to add that value again. I'll put it here. To, I think I have it up here, the walkway thickness. So I'll copy that walkway. Oh, by the way, this reminded me of something. At the very end of class, last class on Tuesday, I noticed that I did something that was really, really confusing to you guys. I had 2 values for walkway thickness when one of them was walkway thickness and the other one should have been walkway width. Yeah, I can tell some of you guys picked up on that, so I apologize. So this is not the walkway thickness. This is actually the walkway width. Or no, I'm sorry, that one is thickness. Wait, hang on. Now I'm getting lost in my own definition. That was walkway thickness. This one is the walkway width, but I called it walkway thickness. So let me revise that. walkway width, and that one was connected to this, so I'll call this one walkway width as well. Walkway, walkway. Yeah, sorry about that, guys. I'm not perfect. Alright, so I'm going to take my walkway width, and I'm going to plug that down here, and what I get is a value of 12.7 in this case. So that's my move to move it off to the other side. So I'm going to borrow move, and actually, let me go back. I'm going to borrow move and amplify and the base normal, but I'm not going to borrow that negative because this is going to be a positive move in that direction. Except I need to replace it and move that geometry instead. Okay, so I moved this one 2 feet out, and then I took this geometry that already was 2 feet out, and I moved it back the other way. It just depends how you string all the arithmetic together. Theoretically, if I left this connected to the other geometry, I would have only had to add the 2.2 plus the walkway thickness once, or the walkway thickness once plus the 2.2 only once, and it would have been fine. But it all comes out in the wash. It's all essentially the same thing. So now you guys understand that the rest of this is exactly the same thing that you've seen 3 or 4 times in this definition already. I'm going to offset the surface. Well, I'm going to loft the surface together. I'm going to offset it. I'm going to deconstruct BREP, and I'm going to do boundary volume to get it all to be solid again. So I'll go to surface freeform and get ruled surface. I'll plug this geometry in there, this geometry in there. That gets me the bottom surface of my bridge. Then I'm going to offset that surface. That's under utility. Offset this here. Change my, I don't know how far I'm going to go, but I'm going to say, whoops, not that. Let me just borrow, yeah, I'll borrow this. 12 inches or so will probably be enough. Plug that in and just amplify it to like a foot. Sounds good. So I'm going to need this surface and this surface to be exploded using deconstruct BREP. So there and there. And then I just need to combine it all. So I will go with freeform ruled surface. I'm going to go edges to edges. That created some solidity. And then I'm going to boundary volume all of them together. So that's under intersect, shape, boundary volume. So that would be my face at the bottom, my face at the top, my face is on the edge, my face at the bottom creates that boundary volume. Turn all this stuff off. What you get is your roof. Yeah, so we did a lot today. We did it in about an hour and 20 minutes. Now, what we've done is we sort of built we did all of this, which is a lot, and then we did all of this. So I want to recap with you so you don't get totally lost, all right? We started off building the armature, right? We isolated the actual edge for the arm curve. Then we isolated the 3 points of that curve and moved the middle point up. That created that arc. Then we moved the arcs. We moved an arc on one side. We moved another one on the opposite side, and that created our top surface. And then we offset that surface to create the bottom surface of the arm. Then we did this, and you've seen this 3 times today. Okay, that just created a solid volume. Now, we went back all the way to our base points, and then we did that base point analysis. We created that side diagram. That was this one right here, which now I can still calibrate. If I don't like where one point is on the end of my definition, I can pull that up. All of this is fully, modifiable. So I can put that back down. I can increase the height in the middle. I can pull up an entire side if I want. So that's really kind of the beauty of this, I think, is that you guys are able to modify this thing in real time. But anyway, let's go back and continue through our recap. So that created the curve. That analysis diagram created the curve that I used to generate this full roof geometry. And then from that, I did a series of, mathematical, quantifications to move that the same way that I created both the base walkway surface, the guardrail, the arm, and then now my roof. It's exactly the same thing. Well, not exactly, but just about exactly the same thing 4 times in a row. Do you guys understand that kind of conceptually, at least? And then, just following that through, we went back to ruled surface, offset, deconstruct B-rep 2 times. And then this was exactly the same thing again. So we ended it with exactly the same thing in our definition, and we had another one up here. Okay? It looks like a lot, doesn't it? Does it feel like a lot when I explain it that way? Yeah, some of you, yeah, some of you not so much. It's okay to feel a little bit intimidated by how many components there are. The thing that I want you to take away from this is that it's really not that complex, because it's just the same idea that you're kind of recycling in slightly different ways every time. Okay? What questions do you have? No? None? All right, so I'm going to color this thing up and then close thoughts. Okay, so I just dropped in, you guys will see that all I did for this was I just dropped in the mesh colors and the deconstruct B-rep here with the deconstruct turned off and the curves turned on so that you can actually see the volume of the bridge. Okay, so if you kind of look at it as a comparison, I think we got pretty close to the actual volume of this bridge. Right, we didn't go into all the structure or anything like that, but we got the gist of the form, right? And I think if you guys wanted to go forward and model out, the columns, the beams that are underneath, those glue lambs, I think you've got enough knowledge that you'd be able to do it. What questions? None? All right. I trust that you're going to be able to actually accomplish this now. More time? Well, that's actually pretty close.
Are you going to want us to have the beams and stuff in our own?
We'll talk on Tuesday about how close to your particular selection you want to make it. So guys, I need all of your attention once more, and actually let me put this on a separate video.